we want to be looking at non-parametric hypothesis. A hypothesis is a claim about a population parameter. The population parameter can be the mean or the median or any other parameter. Now, we have looked at a situation where the sample is parametric or the test is parametric because the sample is normally distributed. I'm sure you remember when we say the sample is normally distributed. Who can remind us what we mean by the sample is normally distributed? You are talking to a 7-year-old child, and you are telling the child that the sample is normally distributed. What does that mean? Who can tell us? What is the best way you can explain this to a 7-year-old child about a sample that is normally distributed? What can you say? Because at the master's level, you should understand when we say a sample is normally distributed, because this is something that secondary school students learn. So you will surely know about it. And for 4 years of going through the university, you should know what a sample that is normally distributed is to easily explain it to a 7-year-old child. William.
Doc, it simply means that all the variables in the samples have an equal chance of being selected.
I'm not talking about sampling distribution. I'm not talking about a simple random sample. I'm talking about a sample that is normally distributed. It's a distribution I'm looking at. You're talking about
Okay, Doc.
the sampling. You're talking about a normal probability sampling. No. I'm talking about the sample that is normally distributed. What does that mean? When we say ages are normally distributed, height is normally distributed, weight is normally distributed. You know, I mean, you guys are smarter. You are smarter than this. Yes, Kwachi.
Yes, so if I were to explain to a 10-year-old, I would say, for instance, if you take height of students in a classroom, if we have, if we count, let's say the number of people in the classroom, let's say 100, and all of them, most of them have a similar height. For instance, the average height is, let's say, 6 meters. I'm just giving an example, 6. And if we find that average and we keep like we find that average, and anytime we try to select someone from that class, they fall within that range, then we can say that's like a normally distributed sample.
Okay. So a sample that is normally distributed is basically a sample where majority of the point are around a similar figure, where majority of the point are on the mean or the average. That is a sample that is normally distributed. Okay. Now, there are some samples that are not normally distributed. Such samples are known as non-parametric. And therefore, the test statistic you use is not the t-test, it's not the f-test, it's not a z-test, that is a different test. Such samples are said to be skewed to the left or to the right. And therefore, and what makes them that? The reason is because the data point itself is ranked. It's not ratio. The level of measurement is not ratio or interval, it's rather more of ranked data, ordinal data. And that is why such samples are usually skewed. For example, if you ask a lot of people whether they like Netflix, is a majority of them going to say that they like Netflix or they don't like Netflix? Are you going to get some people who really hate Netflix? Are you going to get more people who like Netflix and more people who don't like Netflix. Or you're going to get more people who like Netflix. The thing is that you will not have a normally distributed because majority of people are going to like it. So they will tilt towards those who like it more. But if you take the score of you in the class for this course and you check the score, majority of you are going to get very, very around 60% to 70%. And very few will get above 80. And very few will get below 50. So majority of you will be between that 50 to 70. And therefore, that is why we say it's normally distributed. Class scores are normally distributed. All right. I'm sure you understand that. Now let's proceed to the substantive matter. So the table in front of you is showing different kinds of tests that are parametric and non-parametric. As you can see, there are several of them, and I will encourage you to get to know all of them. Know the non-parametric version of any parametric test on the left. So, for example, what is a non-parametric analog of the independent t-test? Who can tell us? What is a non-parametric analog of the independent t-test? Looking at the table, Kwache.
Mann, Whitney,
Mann,
or Whitney.
Mann, Whitney. Very good. Okay. And what is a non-parametric analog of the repeated measures of ANOVA? What is a non-parametric analog of the repeated ANOVA test? Patrick.
Friedman's test.
Okay,
Friedman
very good.
test. Oh.
Excellent. So we're going to look at situations that the data is not normally distributed, okay? And therefore, the way you analyze them is by using non-parametric tests because the data is not normally distributed. They are more ranked, and sometimes the sample size is even smaller. Such data, you have quite a number of outliers. And whenever there is an outlier in a data set, it violates normality assumption. You remember normality, I told you that some are small, some are big, and the majority are in the middle. But where you have one person who can drive everything to the right or to the big side, such data, that person will be an outlier. And when there is an outlier, the outlier makes it impossible for the whole thing to be normally distributed. Majority will no longer be in the middle because the outlier will drive the average away from the center. Okay. So when do we need non-parametric testing? Well, the one we are going to be looking at really is a Mann-Whitney U-test. And the key point why we need this is because in reality, some data are like that. Some data are not normally distributed and they are very good. They are not as powerful as a parametric, especially when normality holds. When the data is normal, use parametric test. When the data is not normal, use non-parametric test. Okay. Now, let's start with one particular non-parametric test. It has two names, actually. One name is known as Mann-Whitney U-test, and another name is known as Wilcoxon rank sum test. It's the same thing. Wilcoxon rank sum. If I were you, but I'm not you, but if I were you, even though you're going to get all the slides, if I were you, I would be writing everything I'm hearing. Because there is a beautiful information symmetry between your fingers and whatever I'm saying. So if I were you, I would have been writing everything. Who is actually writing everything I'm saying? Who is really, really having a book and writing everything? That person has been blessed already up from above. So Mann-Whitney looks more at comparing not the means, but the medians. If you can remember, one of the advantages of the median is the fact that it's able to handle outliers. outliers. It's able to beautifully handle outliers. And that's why the median, because the median, what you do is that you take the center value. You don't calculate all of them. You just pick the center value. You arrange it in a order, and then you pick the center. And so Mann Whitney U test looks more at the medians than the mean. Now, how do you formulate a hypothesis? You simply say that there is no difference in the medians, or you say that the two populations have the same distribution. Okay, that is the equality symbol. That is a two-tailed testing symbol. Then its opposite, it will be there is a difference. So there is a difference, we use what? Not equal to symbol. Whereas there is no difference, we use equality symbol. And the first one, there is no difference, is the null hypothesis, whereas the other one is the alternative hypothesis. So the alternative hypothesis will say there is a difference, which means that one of the medians can be more than the other median. So if you have median 1, okay, you can have median 1 being greater than median 2. Okay, what do you think will be the opposite of this symbol you've seen? Who can tell me? The opposite of this symbol. Class rep, are you there?
Yes, please. Yes, please, Doc.
You are there, right?
Yes,
right.
please.
All right. Who can tell me the opposite of this symbol? Samuel.
Less than.
Less than will be wrong. Millicent.
Less than or equal to.
It's less than or equal to. Okay. So the opposite of greater than will be less or equal to. Which one will be the null? Okay. Of course, you bring M1 here and then M2 there. Which one will be the null? The top one or the down one? Millicent.
The bottom one.
Bottom one, that's it. So you should learn how to actually communicate the null and alternative hypothesis and learn how to clearly write them. So if you were to formulate this very one on your screen, no difference will mean that M1, that is the median for group 1, is equal to the median for group 2. And then the alternative will be that the median for group 1 is not equal to the median for group 2. So this is how you would have formulated the hypothesis. And then, of course, looking at this very one on your screen, is it a one-tail or two-tail? Who can tell us? This one on your screen. Marilyn.
No, please, it's a two-tail.
It's a two-tail test. It is a two-tail test. Okay. Now, I'm going to give you a couple of them for you to tell me how you're going to do the formulation. Okay. Now, before I do that, I'm going to dish out some marks to some people that have been very relevant. Class rep, are you there? I want you to document this for me. Are you there?
Yes, please, Doc.
Okay. So I want you to give 4 marks to Kwache Ado, 2 marks to Millicent. And then let's proceed.
Well noted.
Now, so we want to write a null and hypothesis for the one you see on your screen. The median class size for maths is larger than the median class size for English. What would be the null and the alternative hypothesis? Who can tell us? What would be the null and the alternative hypothesis? The median class size for maths is larger than median class size for English. Kwache?
The null hypothesis would be the median class size for maths.
I'm going to write it for you. So how would you have done?
HO semicolon, HO colon, sorry, M1 is lesser than or equal to M2.
Mm-hmm.
And HA will be M1 is greater than M2.
Very good. Is this one tail or two tail?
One tail.
It is
Right
one
side.
tail. Excellent.
Right tail.
So that's how it's supposed to be. He has executed. That's a 2 mark. Okay. That is a 2-mark execution of the policy angle. So clearly, you can see that, this is how you formulate this particular hypothesis. You must master how to formulate a hypothesis by now. It's the same thing as the one that we knew. The only difference is that in this case, we are dealing with the median instead of the mu. Okay. We're dealing with it. Now, let's take a practical example. And in that practical example, you are going to tell me, because there are quite a number of tests that we have done, but you should be able to distinguish when are we supposed to use this test, when are we supposed to use that test. So look at the data set and then we read the preamble. Kolebu Teaching Hospital is undertaking a clinical trial designed to investigate the effectiveness of a new drug. That is on the right. And the goal is to reduce symptoms of asthma in children. Participants are asked to record the number of episodes of shortness of breath, dyspnea, over a 1-week period following receipt of the assigned treatment. The non-normally distributed data are shown below. I think in this case it's above. Is there a difference in the number of episodes of shortness of breath over the 1-week period in participants receiving the new drug as compared to those receiving the placebo? This is a story. So I have a couple of questions for us to dilate on. First one, what is dyspnea? It was written there. What is dyspnea? Class 12, be ready for me, okay? What is dyspnea? Marilyn?
Shortness of breath.
It is shortness of breath. Very good, 1 mark. Now, what is in this question that gives us the idea that this is not a parametric work, but it's rather non-parametric test that we are going to do? What is the clue here? What phrase or word gives you that? Andrew?
Non-normally distributed data.
Non-normally distributed data. Very good. That is 1 mark. Now, in this question, how would you know that you are actually using a non-parametric Mann-Whitney U-test? First of all, we have already seen that it's non-normally, so it's not going to be parametric. But what gives the clue that it is Mann-Whitney U-test? If you know its parametric equivalent, you will understand this. What gives that clue? Andrew?
Because we have 2 different data sets. So it means that we are going to have 2 median.
You're going to have
2 median.
Oh, you will still have 2 median, even if you are doing other ones. Yes. But there is a reason why it is Mann-Whitney U-test instead of Wilcoxon signed rank test. This is Wilcoxon rank sum test you are going to use instead of Wilcoxon signed rank test. It's beautiful. Wilcoxon signed rank test and Wilcoxon. What was the difference? Elizatar.
I think what you're giving us there is the fact
You have
that
a very noisy background.
sorry about that.
You're not helping you. You are not helping us.
Hello.
Yeah, I can hear you.
Hello.
Sorry. Yeah, come again. Close. Just
Yes,
mute
I'll
yourself
say
and
what
come
is
back again,
given
okay?
the hint.
Because you are not helping my
Yes,
ears. You're not helping us. You are already in a noisy environment, and you know that. So obviously you
Hello.
can't talk. I'm sorry. I said you cannot talk because your place is noisy. That's what I mean. Let me go to Millicent.
So because you are comparing two populations to see if they are from the same. population.
Explain what you mean.
Sorry, please say that again.
Explain what you're saying.
You're comparing these two populations, but you want to see if they're from the same.
No. There's some
Okay.
reason why it is not Wilcoxon signed rank test by Mann, Whitney, or Wilcoxon rank sum. Yes, Patrick.
Okay, so because one, we are dealing with samples that are independent of each other.
How do you know
They are
that?
not
I like that part.
well. Okay, so we are looking at episodes of shortness of breath for placebo and then the new drug. The placebo and the new drug are not dependent on each other. That's how
How
come.
do you know that? It's from the story instead of from the data. Because when you look at the data, they are all 5-5. That might look like you are dealing with dependent sample, isn't it?
Yes.
They are all 5-5, 5 in each group. So what is the point? What makes it really, independent? What makes it possible for a person to use a Wilcoxon signed rank sum instead of signed rank? All right, so I wanted to look at the sentence. It says that it was a clinical trial and they were investigating the effectiveness of a new drug. Watch the word. In reducing symptoms of asthma in children. Okay, a new drug. And now watch the word here. Participants are asked to record the number of episodes, okay, of the assigned treatment. Look at the word assigned treatment. So a participant can be assigned to be treated with a new drug, or another participant to be assigned to be treated with a placebo. So it is not the same participant who is receiving the placebo that is receiving the new drug. It's different participants. And it's from the same. Because you are assigned the treatment. So if you are treated with a new drug, another person will be treated will be given a placebo. And that is how you know that the samples are separate. The samples separate means that they are independent. But to only use the word they are independent doesn't make it clear. You guys say that their samples are separate from each other. There are 10 different human beings instead of 5 human beings receiving, the same 2 different treatments. All right. Next one. What is a placebo? What is a placebo? This one you either know or you don't know. Marilyn.
So a placebo is just like probably giving water with this and that to the patient. They may not really know that it's water, something harmless that is given to the patient instead of probably medication.
Why?
That is to show that you don't want to really give something that it's almost like a control sort of, so that you are not doing anything, but to the patient, something is being administered.
Why will you do that?
Because you want to see the effect.
Why do I have to ask you before you keep going? I have to ask you before you think through. So keep talking. Lecture us.
Okay,
since
okay, so the small I know is that for this one that is a new drug they're administering, they want to see the ones that nothing is being administered, what's the level of the shortness of breath, the frequency of that against the ones that they are administering the new drug. So trying to see the two, you need to have a control, the control being nothing being given to the patient against the one that something is being given to see whether it's effective.
To see whether what is effective.
The new drug is effective in the control of the asthma.
When will it not be effective?
When the shortness of breath, as in the difference between the two, is almost negligible. That means that there won't be any difference between those taking the placebo and those giving the new drug.
Very good. 2 marks. So that shows clearly that you have a clear understanding. This is what I mean by having an understanding instead of using the words here to explain things. Excellent for 2. All right. So guys, you see, anytime you have a question like that, you need to understand the parameters of the question. Appreciate it before you start. Now we're ready to start. Usually, what is the first thing to do when you have a question like this? If it is a real life story that you're doing, which you would do in your thesis, the first thing to do is to check if the data is normally distributed. Now, one particular test to use to determine if the data is normally distributed is a test that is known as, who can tell me? I'll give you some very good marks if you are not cheating. Which test will you use? Anyway, it's known as Shapiro test. But I want us to go back here and look at the data set. From hindsight, does it look like the new drug is effective or is not effective? From hindsight, does it look like the new drug is effective or not? Just looking at the data. And of course, I'll ask you why you said that. Just by cursory glance at the data, is the new drug effective or not? Millicent.
It appears to be effective because they were asked to record the episodes of dyspnea, the shortness of breath. If you look at the one with placebo, the first person recorded 7, second recorded 5, 6 in that order, but those taking the new drug is 3, 6, 4, 2, 1. So they are experiencing less episodes than those on the placebo.
Okay. Very good. Excellent for 2. Okay, so that's from hindsight. So from hindsight, it appears the new drug is what is effective, but we have to subject this to statistical torture. We've got to pass it through a statistical testing. In this case, Wilcoxon rank sum test or Mann-Whitney U test. And then we can conclude whether this difference is statistically significant or insignificant. Okay. So we use a Shapiro test, first of all, to determine the normality, to test for the normality, whether the data is normal or not. Okay. Now, I had to do a Shapiro test. I had to also do a graph. But let me just give you a clue. If you ever do the Shapiro test and you observe that the p-value is bigger than the alpha, then it means the sample is normally distributed. Okay, take note. If the p-value is bigger than the alpha, then the sample is normally distributed. But if the p-value is less than the alpha, the sample is not. If the p-value is bigger or equal to the alpha, it's normally distributed. But if it's less than the alpha, it's not normally distributed. So let's look at a little bit of the histogram, the distribution, just from graphical interpretation. Does this graph look like it is normally distributed or it's not normally distributed? Who can tell me? And of course, you have to tell me why. Does this graph give you the impression that it is normally distributed or is not normally distributed? Pache.
It gives me the it gives me the impression that it's not normally distributed because looking at the graph, it doesn't form like a bell shape. It almost looks jagged, like a jagged image. It doesn't feel like a bell shape with the bars that we have here. Because on the far left, we have one which is high. On the number 7, we have another one which is high, and some Lulu
Which
ones in
particular
between.
bar actually destroys the normality?
I would say
There are about 3 of them that
5.
destroy the normality, or 4 of them.
Yes, 1, 5, 7,
Good. You have some
and 3.
ideas. You have some ideas. Okay. So if we are to pass a kernel density plot through them, will it be unimodal, bimodal, or multimodal? If you pass a kernel density graph through these, bars, will it be unimodal? In other words, will it be one mode? Will it be bimodal? That is two modes. For those of you who don't know, unimodal is like this. Bimodal is like that. So you have two modes. Multimodal is like that. That's three or more modes. Which one is this likely to exhibit? Kwachi?
Multimodal.
Multimodal, very good. You got 2 marks now. Okay. So it's very, very important to reflect these things there. Okay. Now, we are ready to do the test manually. So the first thing to do is to formulate the hypothesis. Let's go back to the storyline and see what is the key word that can help us to formulate a hypothesis. It says that Colombo teaching is undertaking a clinical trial to determine the effectiveness of a new drug. Towards the end, it says that, is there a difference in the number of episodes of shortness of breath over a 1-week period in participants receiving a new drug as compared to those receiving the placebo? What will be the null and the alternative hypothesis? Let's get there. Let's get down there, Millicent. Let's really
The word
think
guide
deep.
in it is there a difference?
Good. So how will you write it from the hypothesis?
So H naught colon is it a mu of the, is it a median?
Are you asking me? Because we've learned it.
Okay, mu of the placebo is
No,
equal
let's
to,
another person help us.
okay,
Because you didn't think that part before you raise your hand. Who can tell us how to formulate the hypothesis? Marilyn.
Okay, so the H naught would be M1, which probably the median for the placebo, minus M2 median for the new drug is equal to 0. Then the HA would be M1 minus M2 not equal to 0.
Very good. Very good. Excellent for one. So that is how you got to write the null and the alternative hypothesis. But you also have to know what it means. Writing it is one thing. Understanding what it means is a whole new ballgame. So what is the alternative hypothesis is saying? In principle, the alternative hypothesis, what is it really saying? If you are to think it, because you see, the null hypothesis is saying that there is no difference. What does that mean? What it simply means is that the new drug is useless. It's bogus. There's no difference between the new drug, the number of episodes of shortness of breath, between the new drug and the placebo. There's no difference. So why do you bother yourself to go and create a new drug? Irrelevant. The alternative hypothesis is saying that the placebo group is not the same as a new drug group. So it goes 2 angles. But which angle do you think that we'll be looking for? It goes 2 ways. Either the M1 is greater than the M2 or the M2 is greater than the M1. Which one should it feasibly go to for one to say that, yes, that's an alternative? If the null is saying that there is no difference, then the alternative will imply what? In connection with this. Because it's not equal to, yes, Millicent, try.
the alternative should be saying that the new drug has an effect.
So how will you write it?
So M2 is greater than M1.
No. From what you said, M2 was a new drug.
Yes, the effect of M2 is more than the effect of M1.
No. It can be because we are talking about the number of episodes of shortness of breath.
Episode. Oh my God. Yeah, it's less than.
And
Sorry.
you want
So
the episodes to be less
yes. So
for the new
NP
drug to be
less.
effective.
Yes.
Understanding is critical, guys, in formulating these hypotheses. So you would expect that M1 will be less than the M2. Sorry, the M1 will be greater than the M2.
Yes.
Okay, for the alternative. That is for the effectiveness of the new drug. So that's how you do. But our original hypothesis is what you see, not equal to. You got to do that and explain it for 5 marks in exams. So the first one says there's no difference, and the second one says there is a difference. Okay. You would also have to write it in English, not just in this format. Now, is this a one tail or two tail? This is a very easy question. You should always identify that before you move on. Is it a one tail or two tail? Sylvia, welcome to the club.
Thank you. Two-tail test.
It's a two tail. Now, from this, what is the value of alpha? What is the value of alpha? Millicent.
It's 5% since we weren't given any.
Exactly. It's 5% because we have not been given this particular work.
A question, please.
I'm not, yeah,
Doc,
go ahead.
a question. Please, in the exam, if you're writing the alternative and the now, are you supposed to explain as well? Like put in words before.
With the top, like at the top.
Yes, you're supposed
Yes.
to put that. Okay.
Yes. That one is even more marks than the other one you write.
Okay, thanks.
And you have to explain it with practicality. You see, after the first one, there's a proper practicality. New drug is more or less effective. I gave that from this, but of course, it will be more effective from the principle we've just discussed. Now, how do you go about your hypothesis? This is the most important time. After you've written your hypothesis, the step 2 is always to find the test statistic. Do you remember? Now, to do the test statistic, you got to take the entire data set and mix it all together. Listen carefully. Mix it all together. And then you start writing them in ascending order. So I'm going to create a table here. And in this table, I'm going to have placebo here for P and new drug here. Okay. Now, we are going to now list them. We'll pick the first one in ascending order. Okay. So let's go back here. And then you see the data set. So this is the data set. If you are to look at it very carefully, the first number that will come is what? What is the first number? And then you tell me which group it belongs to as well. In ascending order, the first number is what?
4.
Yes. Shout the answer.
4 for placebo.
No, it's not.
1 for new drug.
It's 1 for the new drug. That's the first number. This is it. The first number that comes is this one here. So you write 1. The second number?
2
For
new drug.
2 for new drug. Next number?
3
For
new drug.
next number?
4
For
New drug and
new
placebo.
drug and placebo.
so you will normally say both. Okay. So you write 4 here, you write 4 there. Next number?
5
For
placebo.
next. Next.
6 for both.
So you write it here, you write it there. You can see that you are climbing, ascending. Next.
7
For
placebo.
next.
12 placebo.
Exactly like this. So you got to organize it beautifully like this. And you can see the way I wrote the pairs. Now pay attention. You are going to create another column, 2 other columns, which are going to be the ranks. So you're going to have the rank 1 for the placebo, and then the rank 2 for the new drug. Now remember, these ranks are positions that we are going to give to these numbers. The numbers could have been 20, 30, 42, 43. And when we are starting positioning them, we would have still positioned them as first, second, third, fourth, fifth, and then on and on. But the word first, second, third, fourth, and all of that, I will use things like 1, 2, 3, 4. But I don't want you to confuse them with the 1, 2, 3, 4 that have been written here. Okay. All right. If you are ready, let's start. So we'll take them in that same order in which they are. The first number is 1. Which position would that be? It will still be number 1. Okay. And it is in which group?
New drug.
New drug. So you write number 1 here for that new drug. The next one is 2. And it will still be given a position of what? 2. So and it is in new drug. So you go to R2 area. Actually, you can call it rank placebo. In fact, you can just call it rank placebo here, and then rank new drug here. And then remove the 2 and 1. All right. Cool. Now, let's proceed with the ranking. The next rank is number what?
Number 3.
Which group?
New drug.
New drug. The next rank is number what?
4.
Okay. But 4 is a tie. See, 4 is for both. So the ranks, and this is where you got to pay attention. The ranks, whenever there is a tie, the rank must be added. So you still go ranking, but you got to add the ranks and find the average of the ranks when there's a tie. I'll give you some 2 examples so you appreciate it. So suppose you have a tie like this. You are going to number 4. You are going to number 4. But this were the numbers. They were 8, 8, 8, 8. So this first 8, let me use a different color for each of. This first 8 would have been number 4. This one would have been number 5. This one would have been number 6. And this one would have been number 7. So what you got to do is to find the average of the ranks, not the average of the numbers, but the ranks. So you're going to take the 4 plus the 5 plus the 6 plus the 7 divided by what?
4.
4. Okay. So you take this thing and you have 9, what do you call it? You have 22. Is it?
Over 4.
Okay, exactly.
5.5.
So you have 5.5. Now you're going to distribute that 5.5 to each one of them. So this one will be given a rank of 5.5, a rank of 5.5, a rank of 5.5, and a rank of 5.5. So what you've done is that because they were ties, you add the ranks and find the average of the ranks and share it for all of them. But when you are done with that, remember the last number was what? 7. So when you're going to the next number, the rank should be what?
8.
8. You don't miss your ranking. Don't say that because this one is 5.5, then the next one should be 6. No.
Okay.
You continue your rank as it is. You only shared the paired rank with them. This is the only trick in Mann Whitney. No other trick. Nothing else. Okay. So let's come back here to our own. We are on number 3. So for the 4 and 4, what rank are we going to have?
4.5.
4 plus 5.
5. You share it for both of them. So you give 4.5 to this one and give 4.5 to this one. The next number is 5. What rank is that? 6. Okay, and you don't forget that it is in the placebo group. The next number is 6 and 6. What ranks are they? What ranks are they?
7.5.
7.5 each. Okay,
Yeah.
so you give each one of them 7.5 and then 7.5. The next number is 7. What rank is that?
9.
9. You don't forget because we did dealt is 7 and 8. Okay, so the next one is 9 in your head. So this 7 will be given a rank of 9. Don't forget that it's in the placebo group. So you write it in the placebo group. The last rank is what?
10.
10.
10. For which number?
12.
Placebo.
Placebo.
12 in the placebo. Okay, so you now write 10. So at this stage, you have all the rank beautifully. And then you normally will come to the bottom of this and then find the total rank here and the total rank here. This will be given a total rank called R1, and this will be given a total rank called R2. So you will now sum them vertically downwards, and you will find the total. That's it. I have to just do it like this so you can understand. So now let's see what we did here. Okay, so these are the ranks, as you can see. They've all been done here. But what I did was better because what I did is already putting them in groups. But here I'm writing the groups as I keep going. But the one I did for you is better. Now you will add them, R1. So please, somebody should find me the total ranks for the R1. I hope you were writing when I was writing. I hope you were not just looking at me.
R1 is 37.
R1 is 37. Okay, so you write R1 is equal to 37. And then R2.
18.
18. That's it. So now you have your total ranks. At this stage, there is a first commandment you should check to know that you are right. Okay. There's a first commandment you should check to know that you are right. It's a very powerful commandment. The commandment says that the R1 plus the R2 should be equal to N1 times the N2. Hey, wait. The R1, just a second. Let me just go down here. Okay, so these are your ranks, the total ranks that we have. Okay, so this is the first commandment. I just want to show you so that, okay, it says that the sum of R1, I think that's what I did. Okay, the sum of R1 plus the R2 should be rather equal to N outside, N plus 1 divided by 2. N outside. Now, what is this? This is just to check whether you're on the right track. So you take your two numbers, okay, which is a R1 and R2, sum them, and then you take the N, and then into bracket the N plus 1. By the way, what is N? Who can guess what the N? Sorry?
Sample size. Sample
What is
size.
that?
10.
What's the value?
10.
10. Okay, so N1 is 5, N2 is also 5. When you put them together, you get N. So when you do this summation, do they balance? Do they balance? Double check before you proceed. Because the moment you check and they are not equal to each other, you are wrong somewhere. The moment you check and they are not equal to each other, you are wrong somewhere. So let's take the values here. You have 37 here plus 18. That will give you what? 55.
55.
Then you have 10 here into bracket 10 plus 1, which is 11 divided by 2. 10 plus 1 is 11. 10 times 11 is 110. So the numerator is 110 divided by 2. That will give you what?
55.
55. So at this stage, you can walk to the examiner if you are doing an examination and you can slap the examiner, no problem, because there is no way you are failing. Commandment number 1 tested. Now that you've done this, you can now proceed and calculate your Mann-Whitney U statistic. Let's do that. Okay. By the way, this was a check that we did. And then you can see that they are all 55. There's a test statistic for finding the Mann-Whitney U statistic. There are 2 of them actually. And the reason is because there are 2 ranks. Okay. Because there are 2 ranks, 2 total of ranks, there are 2 of these. So and I'm going to ask each one of you all of you to calculate. You are going to do for U1. So U1 is actually, write this, is the total rank in group 1 minus the sample size in that group into bracket the sample size plus 1/2. And then the same thing, U2 is going to be the total rank in group 2 minus the sample size in group 2, which is 5, into brackets 5 plus 1 divided by 2. Find the 2 U's. And when you're done, send me your answer. In fact, when you're done, raise your hand. When you're done, you raise your hand for the 2. I want to dash something. You will notice that even if it is an exam, sometimes you are good, but the speed is of the essence. Speed is of the essence. Speed is of the essence. Okay, Felicia, send me your answer privately. You've not even spoken today. Felicia, okay, tell me your answer. Shout your answer for me. All 2. Felicia, shout your answer for me before I give it to another person. Paris, go ahead. Shout your answer for me.
So I had U1 to be 22 and U2 to be 3.
Very good. That is 2 marks. Okay. So guys, if you should work this thing well, you should get the U1 to be 22. And then you should get the U2 to be 3. So it's very, very simple. Now, which one do you use? Because only one of them is a U. Who can guess which one do you use? Which one do you use? I mean, you got to take a guess, but a calculated guess.
U2. U2.
Why? It's lottery. Anybody can say it.
U2.
You keep saying you too. I say, why? You say you too. Sylvia.
So please, I want to ask a question. I couldn't join from the beginning. I'm finding it difficult to find which one is N1 and N2.
N1 is a sample size for the first group. N2 is a sample size for the second group. So let me just quickly show you. This is a data set. M1 is the total number of samples in group 1. That is 7, 5, 6, 4, 2, 12. That's 5 people, 5 observations. Then N2 is the second group, the new drug group. You can see that there are 5 data points.
Yeah.
That's it. Are you okay now?
Thank you. Yeah. And I can see into bracket 6.
There's no into bracket 6 here. No.
Okay.
You just substitute it
I
into the formula.
Yeah, I get it. Okay, thank you.
Okay, so you take the smaller one, and the person was not able to tell us a reason. There are 3 reasons. Take note of one. The reason why we are using the smaller u is because it represents the most extreme deviation from the null. It is a one that shows the most, because remember that the null hypothesis is there is no difference, which means there's equality. Okay, there is no difference. Is that it? There is no difference.
Yes, please.
Yes.
It means they are equal. Okay,
Yeah.
they are equal. Now, that is what the null is saying. So which one will be, in terms of the difference, 22 is saying that if they are going to be equal, then the gap shouldn't be so wide, isn't it? If they are going to be equal, the gap between the two shouldn't be so wide. The median between the two, the population median shouldn't be so wide. But the 22 implies that the gap is so wide. The 3 implies that the gap is small. That's the first one. Also, when you go to the critical values, and we're going to use the critical values very soon. When you go to the critical values, they use smaller samples. The actual critical values, the Mann-Whitney U table was built using smaller U. So that is the second reason. So the smaller U matches the stronger evidence against the null hypothesis, because the smaller U actually means overlap, less overlap between the groups. So that's why you use the smaller U. Okay. Now, second commandment, Frederick.
Prof, so does it mean
I can't
that
hear you
we
at all,
always...
Frederick.
Hello? Hello, can you hear me now?
Amplify your voice, Frederick.
Yeah, Prof, can you hear me, please?
Yeah.
Yeah, so I'm asking that, does it mean that we always pick the minimum U for
Yep.
it, or depending on the null hypothesis?
Always a minimum.
Okay, thank you.
Now, the second commandment is to check whether what you've done is correct. So the good thing about Mann-Whitney is that you can always know whether you're on the right track. The second commandment is a very simple commandment. It says that the U1 plus the U2 should always be equal to the N1 times the N2. So calculate and tell me whether that balances. Calculate and tell me whether commandment number 2 is passed.
It's passed.
It's passed. They give you what?
25.
Exactly. So when you check carefully, you see that the two of them will give you a value of 25. So it means that you're on the right track. You can slap the examiner one more time. At this stage, you have your test statistic. And the test statistic is 3. The next is to find the critical value. It's a very simple formula to find the critical value. Now, the critical value must be found using only the Mann-Whitney table. What is that table? Well, the Mann-Whitney table is a beautiful table that will help you get the critical value. There is a formula to finding it. As you can see here, it says that the critical value, to get it, you need the N1 value. You also need the N2 value. That is a sample size in group 1, sample size in group 2, and then you match it against the alpha. And we know that when alpha is not given, what is the value?
5%, 0.05.
So at this stage, you open your Mann-Whitney U table. I think I gave you all the U table, Abby. Do you remember the Mann-Whitney U?
Yes, please.
Very good. So you're going to take your Mann-Whitney U table. Okay. Take that table and move along with me. I know some of you are waiting for me to rather show my table. But then it's also good for you to show your table. So who is showing whose table? Okay. Now the table is of 2 types. Let me just show you something about the table. This is a Mann-Whitney U table. The table is of 2 types. You have the two tail at the top, and then when you go to the second page, you have the 1 tail at the down. Okay, so you got to decide which tail you are dealing with before you go to which page. In our case, which tail are we dealing with?
Two-tailed.
Two-tailed. So you have to use the two-tailed version. Now, when you look on the far top, you have N1 here, which means that the horizontal numbers at the top are the N1. All of these are the N1. The horizontal numbers at the top. Okay. Then you have the vertical numbers on the far right. They are the N2. Remember that the formula was U subscript N1, N2, and then alpha. N1 is what? 5.
5.
What?
5.
5.
5.
Alpha is 0.05.
5.
So you will look for 5 at the horizontal top and look for 5 at the horizontal far left. And for each one, you see that there is an alpha value given. So each one will have an alpha value of 5% and 1%. And match the one you are dealing with. And then tell me the critical value. They will meet at the junction. Who can raise a hand and tell me the critical value? Sylvia. Sylvia.
2.
Exactly for 2. Okay. So that is 2. So our critical value is 2. So when a student writes 2, I know that a student has gone through some mental, torture before actually coming with a 2. Okay. So now you have gotten your critical value. You are good to rock and roll. You are ready to conclude. So we go to our this thing, and then you see that the critical value is 2. Now that you have gotten that value, you are just going to compare it with the test statistic. Do you remember what our test statistic was? Who can remind us?
It was 3.
It was 3. Okay. So the rule is that reject the null hypothesis if the test statistic reject the null hypothesis if the U statistic is bigger than the critical, is less than the critical value. If the U statistic is less than the critical value. Okay. Now, you remember that the parametric test, it was rather when the test statistic is greater or equal to the critical value. Do you remember? That's when you reject the null hypothesis in the parametric. In the parametric, when the test statistic is bigger, you reject. But in the Mann-Whitney, the non-parametric, when the test statistic is rather smaller, you reject. Keep that in mind. Now, in our case, is the test statistic smaller?
No.
Bigger.
It's bigger.
It's bigger. So are we rejecting or we're not rejecting? Have I swapped them? Let me be
They are
sure.
not rejected.
We are not rejecting.
Exactly. We are not rejecting. So we are going to conclude, and this is a conclusion. It says that since the test statistic is rather bigger than the critical value, we fail to reject the null hypothesis. What was the null saying? The null was saying that there is no difference, isn't it? We are not rejecting it. So we are endorsing that there is no statistically significant difference in the number of asthmatic episodes between the placebo and the new drug groups at the 5% level of significance. There is no statistically significant difference, which means that the new drug is what? Which means that the new drug is what?
It's effective. Or the new drug is...
It's not effective.
It's not effective. The new drug is ineffective. I didn't bring that, but that is the most powerful conclusion you can ever make. And that conclusion alone is 8 marks. That practical conclusion alone is 8 marks. So you got to really understand what you are doing so that you can conclude very well. Now, for this particular exercise, I'm not going to bore you to find the p-value. The complexity associated with, you have to use a lot of combinatorics to be able to find the p-value and compare the p-value with the alpha. I didn't want to bother you. And in any case, in practical work, the software will do it for you. So this is not something I'll bore you with it at all. So this is an example of a Mann-Whitney U-test. The sample size is less than 30. The data is not normally distributed, and you use a Mann-Whitney U-test. Ladies and gentlemen, that brings us to the end of the entire caboodle. At this stage, I'm going to accept questions. If you have anything that didn't click well, this is it.